Welcome back. This is an Aleks training video on recognizing S and P orbitals. If you remember, an orbital is a room for two college girls that hate each other. So what they actually are is a probability. It's a region of space that you can probably find an electron, that there's a probability or more and more of a higher probability that you would find it. So in terms of shapes, you have to think of as a cloud or just a region where you're likely to find someone. Okay, so if you were to take my day and put a dot everywhere I am during the day, you would likely find me at school. And you would see that at school, there would be lots and lots and lots and lots of times that I'm at school, and likely you'd find me at school. So if you had to find me, the probability of finding me at school between certain times would be very, very high. The other probability would be finding me at home. So either I'm at school or I'm at home, and so I've got two locations of probability depending on the time. And the probability of me being in Phoenix is probably very, very low. Okay, or me being in Tahiti. Okay, so what you're going to see is anywhere that you don't have the shape, you have a very low or zero probability of finding an electron. If you have a shape, the area of the cloud or the part of the space that's occupied by the cloud would be a higher and higher probability that you would find it. Okay, S's have a shape relatively spherical. Okay, so if you have a sphere, this is going to be an S subshell. So anywhere in this region of space would be where you would find an electron. Anywhere here, for instance, it would be a 0% chance that that electron would be there at that distance. When you get to P subshells, remember S's only have one orbital. The S subshell, one orbital. That means that one electron is going to be here and the other electron here, spinning in different directions. They're always avoiding each other, trying to stay away from each other all the time. They're always trying to get away from each other. So these two electrons are just going to stay in this region of space, whirring wherever they are, and they're going to be at 180 degrees from each other, every place that you can imagine, because they hate each other. They're both negative and they want to avoid each other. So if you have one orbital in the S, in the P, you're going to have three orbitals. That means you're going to have three rooms, 6 electrons. So you have 2 electrons in the S, but you're going to have 6 electrons in the P. And so you're going to have regions of space along axes. So if you have an x-axis here, like in algebra class, and you have y-axis, which is an up-down, 90 degrees to the x, then you have to think three-dimensionally, and coming straight out would be your z-axis coming in, into the board and out of the board would be the z. So what statistically or mathematically, the probability-wise of finding an electron in this region of space is going to be much more shaped like a dumbbell. Okay, so you're going to have kind of this along the x-axis, and this would be your x orbital. And you're going to have one electron here and one electron here, and they're avoiding each other. So the node, this is called a node. The node is where there is no likelihood of finding an electron. This region of space is where there's a high likelihood of finding an electron. You can see that the y, you're going to have the same shape. It's just going to be along the y-axis. And the z is going to be the same shape. It's just going to be along the z-axis. So it's like 3 sets of dumbbells. Okay, so there is an x-axis, y-axis. This is y-axis, and this is z-axis. So this is the P sub x subshell, P sub y subshell, P sub z subshell. So here's your questions. Along these pictures, A, B, C, and D, are there any of them s orbitals? Well, do you see an s orbital shape? Yes, this is an s orbital. So the answer is yes. List the s orbitals, if any. It would be option C. Are any of them p orbitals? Okay, well, A p orbital, remember, is a node in the middle and a high likelihood on two ends. So D would be 1, and also B would be 1. This would be the piece of X, and this would be the piece of Y. So yes, and then which ones are they? It would be the B and the D. Okay, I hope you're learning.